Lesson 13.5, we're looking at box and whisker plots. You'll learn to organize and use data in box and whisker plots and organize and use data in parallel box and whisker plots. How are box and whisker plots used to display data? Everyone should eat a number of calcium-rich foods each day. Selected foods and the amount of calcium in a serving are listed in the table. To create a box and whisker plot of the data, you need to find the quartiles of the data. To find the quartiles, they've listed the data in order from least to greatest, and then this happens to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces of data. So the median is halfway between 7 and 8, so 7 pieces of data on each side. So that means our Q1 is going to have 3 pieces on either side of it. So our Q1, our first quartile, is at 163, and the same way our third quartile is going to have 1, 2, 3, and 1, 2, 3 on either side of it. So the third quartile is going to be at 300. The information can be displayed on a number line as shown below. So we have the least value is at 89. There's our quartile 1. Our median, which is quartile 2, but it's normally labeled median, quartile 3, and the greatest value. Diagrams such as the one above are called box and whisker plots. The length of the box represents the inner quartile range, the difference between Q3 and Q1. The line inside the box represents the median. The lines or the whiskers represent the values in the lower fourth of the data and the upper fourth of the data. The bullets at each end are extreme values. In a box and whisker plot below, the least value is 89 and the greatest value is 452. If the set of data has outliers, which are values that are 1.5 times the inner quartile range above or below Q1 and Q3, then those data points are represented by bullets or sometimes little asterisks. Just trying to draw asterisks, something like that. The whisker representing the lower data is drawn from the box. The least value is not an outlier. The whisker representing the upper data is drawn to the box to the greatest value. It's also not an outlier. The average water level in Lake Travis in central Texas during August is a good indicator of whether the region has had normal rainfall or is suffering from a drought. The following is a list of the water level in feet above sea level during August for the years 1990 to 2000. They ask us to draw a box and whisker plot for these data. First, we need to list the data in order from least to greatest. And conveniently, there are 11 pieces of data, so our median, or Q2, is going to be 1, 2, 3, 4, 5, and then there's our sixth one. It should leave us 1, 2, 3, 4, 5 on the other side. And then for Q1, there's 2 and 2, so it's the middle of the bottom half, and Q3, 2 and 2, is the middle of the top half. The inner quartile range is the difference between Q3 and Q1, so 677 minus 664, or 13. And we use the inner quartile range to check for outliers. So if we take our Q1 minus 1.5 times the inner quartile range, we get 644.5, and Q3 plus 1.5 times the inner quartile range, we get 696.5. And I do not have anything that is less than my 644.5, or do I have anything that is greater than 696.5? So I have no outliers in this set of data. So now I can just make myself a happy little number line and plot my points, my minimum, Q1, Q2, Q3, and my maximum. And we're just going to take a straight edge and we're going to draw a box around the inner quartile range. And this line represents the median. And I've got one whisker going up to my max and another longer whisker going down to my minimum. What does the box and whisker plot tell us about the data? Well, looking at our picture, it sure appears that the upper half of the data are less spread out than the lower half. Okay, they gave us some unfortunately realistic data for the average yearly rainfall for 11 major cities, and they asked us to draw a box and whisker plot. I'm bemoaning the fact that they went to the nearest hundredth, but anyway, there's 11 pieces of data. So when we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I have them all, that's good. So it should be my sixth piece of data, should be my median. 1, 2, 3, 4, 5, 6. And just counting again, 1, 2, 3, 4, 5. Yep. Okay, so my median is 37.39. And then conveniently, I'm going to have 1, 2, 3, 4, 5 pieces of data above and below. So that makes this guy Q1 and this guy is Q3. It gives us an interquartile range of 10.22. So when we go to check for outliers, we'd have outliers of anything below 18.01 or anything above 58.89. Oh, hello. That means 11.37 is an outlier. So we don't connect that as part of our whisker. We still plot it because we need to acknowledge it's there, but our whisker then goes from the 30.94 into Q1 was 33.34. There's our median at 37.39. Q3 is at 43.56, and our maximum is at 49.7. What does the box and whisker plot tell you about the data? Except for the outlier, the lower half of the data is less spread out than the other half. It's convenient to compare two sets of data by drawing parallel box and whisker plots such as the one shown below. Pilar, who grew up on the island of Hawaii, is going to college in either Dallas or Nashville. She does not want to live in a place that gets too cold in the winter. So she decided to compare the average monthly low temperatures of each city. Draw a parallel box and whisker plot for the data. So they're basically getting us to do two problems on the same number line so we can compare them. So for Dallas, we have to arrange them in order from least to greatest. Find the median, find Q1, find Q3. And repeat the same process for Nashville. Luckily for us, neither one of the cities has an outlier, so we don't have to worry about them. So now they can draw them on the same number line, and there is our minimum for Nashville was 26.5, Q1 was 35, the median's 47.9, Q3 is 62.9, and the maximum is 68.9. For Dallas, the minimum was 32.7, Q1 is at 41.5, the median is at 55.25, the third quartile is at 68.45, and the maximum was at 74.1. So now we have all our data drawn out in parallel box and whisker plots. We should compare. Well, we can see that they both have about the same interquartile range, but all the quartiles for Dallas are shifted to the right of those for Nashville, meaning Dallas has higher average low temperatures. Could have told you that. In a box and whisker plot, the vertical rule or line represents the median. The box and whisker plot represents the box is the interquartile range, and the bullets at each end are extremes. Parallel box and whisker plots can be used to compare data.